Hello and welcome to the Theory of Computation lectures. In this class, we will discuss about some problems on NFA. So the first problem that we take is to design a NFA over input alphabet 01 to accept strings ending with 11. As usual, if you look at the language that is going to be accepted by the NFA, the language will consist of all kinds of strings that end with two ones. So the design of the NFA starts with an initial state A, and in A, if we receive input 1, we go to state B. In state B, if we receive another 1, the machine goes to a final state F. Now, this is the final state, and if the machine receives anything before receiving two ones, it can remain in a loop in the initial state. So that is a very basic simple design of an NFA which accepts strings ending with two ones. Now some observations over here is, firstly, there is no requirement of a dead state. Secondly, there is a loop on the initial state to indicate that the machine can receive whatever input it gets until it gets two ones to end with the final state. Thirdly, if the length of ending substring is 2, then the number of states is 3. Okay, so let's take the next problem. This is a similar problem in which we have to design a NFA over input alphabet 01 to accept strings ending with 101. So if you look at the language that is going to be accepted by the NFA, once again the strings that end with 101 are all accepted by the machine. So if we design the NFA starting from initial state A, on A if we receive input 1, we go to state B. On B if we receive input 0, we take the machine to state C, and then on C if we receive input 1, the machine goes to a final state F. And as before, whatever we receive before receiving 101 doesn't matter. We can put a loop in the initial state to indicate that the machine can receive any number of inputs until it receives a 1, a 0 and a 1 to go to the final state. Again, observations on this state. Firstly, there is no requirement of a dead state. Secondly, there is a loop on the initial state as we saw in the previous case as well. Thirdly, if the length of the ending substring is 3, then the NFA has 4 states. So in general, if the length of ending substring is n, then the accepting NFA will consist of n plus 1 states. Okay, so let's look at the next problem. This problem is to design a NFA over input alphabet 01 to accept strings containing substring 01. Now as you remember, in the case of a substring, the substring may occur in the beginning of the string, or it may occur in the end of the string. It may also occur in the middle of the string. So if you look at the language will consist of all possible strings in which the substring could occur in the beginning, as in these cases, or in the end, as in these cases, or even in the middle, as in these cases. So all these kind of strings should be accepted by our NFA. Okay, so let's start the design starting from the initial state A. In state A, if we receive 0, we go to state B, and in state B, if we receive a 1, we go to a final state C. Now in this case, if we receive something after this or something before this, still the strings should be accepted. So we will put two loops, one on the initial state and one on the final state. So whatever we receive before receiving a 0, 1, after that if there is a 0 and 1 consecutively, then it's a substring. Similarly, after receiving a 0, 1 consecutively, whatever we receive, still the machine has received a string on which 0, 1 is a substring. Hence all these kind of strings should be accepted. Observations: firstly, no dead state. Secondly, there is a loop on both initial and final states. Okay, and thirdly, if the length of the substring is 2, then the number of states is 3. Let's look at another problem which is similar to this. Again, we have to design a NFA over input alphabet 01 to accept strings containing substring 100. Now again, as before, the strings may start or end with 100 or may contain 100 in the middle. So our design will start with an initial state A, in which if we receive 1, we go to state B. On state B, if we receive 0, we go to state C. And in state C, if we receive 0, we go to state F, which is the final state. Now, in case of a substring, as we have observed in the previous example, whatever we receive before receiving 100 or after receiving 100 doesn't matter. As long as we have these three symbols 1, 0 and 0 consecutively in our string, whether in the beginning or in the end or in the middle, the string should be accepted by the NFA. So observations once again, date state is not required. Secondly, loop on the initial and the final state. Thirdly, if the length of the substring is 3, then the number of states is 4. So in general, if the length of the substring is n, then the accepting NFA will consist of n plus 1 states. So in this class, we discussed some problems on NFA. In the next class, we will continue this and discuss some more problems on NFA. Thank you.